Hello, welcome to Scholar Fedu. This is our JAMB prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2015. This is the first part of the recording. We are going to be looking at the first 20 questions. Before we continue, please don't forget to subscribe to our channel, like and share content. You can also visit our website at scholar.com to practice the UTME exam and modular quizzes for free. Our first question here on elasticity. A piece of rubber 10 centimeter long stretches 6 millimeter when a load of 100 Newton is hung from it. What is the strain? Okay, the strain is given as the extension over the original length. Now from the question, the original length of the rubber before it was stretched is 10 centimeter. Okay, now the question says or with a piece of rubber 10 centimeter long stretches 6 millimeter. Stretches 6 millimeter. I mean, this is the extension produced in the material when a load of 100 Newton is hung from it. That is when a load of 100 Newton was hung from the rubber stretched or extended by 60 millimeter. So here we have the extension, and that's what we really need to calculate the strain: extension and the original length. So however, if you look at the original length here, it is given in centimeter and the extension is given in millimeter. We cannot use them directly here in this formula. So what do? We need to convert them to a common unit. Okay, we cannot use centimeter and millimeter directly together. Okay, so we convert them to a common unit. So what we've done here is convert this, okay, the length and the extension to meter. Now here we have 10 centimeter, so we convert from centimeter to meter, and to do that we divide by 100. So you have 10 divided by 100, and that is 0.1 meter. To convert the extension from millimeter to meter, we divide by 1000. So you have 6 divided by 1000, and that is 0.006 meter. Now we have the length in meter and the extension in meter. We can then use this formula here and substitute. So the strain is extension, which here is 0.006 meter, divided by the original length, which is 0.1 meter. 0.006 divided by 0.1 is 0.01. Writing this in standard form, we have 6 times 10 raised to the power minus 2. The reason why this is minus is because this is a number that is less than 1. Okay, this is a number less than 1. Also, it is we have minus 2 here because we have, of course, 2 zeros before the first significant figure here, before the 6 that we have here. So this is 6 times 10 raised to the power minus 2. Next, on optics, the diagram above shows the lens arrangement in. What we have here is the ray diagram, okay, for the compound microscope. The arrangement here is that of, okay, the lens arrangement in a compound microscope. Next question on electricity. What is the total resistance in the above diagram? So here in this diagram we have some resistors connected in parallel and then in series to some other resistors here. So what do? How do we find the total resistance in this circuit here? Okay, or in what we've been given here? This is not a complete circuit. So what we do is the resistors that are in parallel, we are going to find the effective resistance. Okay, for these two resistors in parallel, we find the effective resistance. Whatever we get is now going to be in series with these other resistors here. Okay, so when you have two resistors, let's say R1 and R2, that are connected in parallel, then their effective resistance R is going to be 1 over R equals 1 over R1, which you can say here is, say, 10 plus 1 over R2. Okay, that's another 10 here. So you have 1 over 10 plus 1 over 10. Now a simple way to add this is, since the denominator of the fraction is the same, is equal, we simply add the numerator or operate on the numerator, and we have addition here, so we just add the numerators together. So we have 1 plus 1 divided by that common denominator, which is 10. 1 plus 1, that is 2 over 10. If you reduce that to the lowest term, you're going to have 1 over 5. So you have 1 over Rp, which is the effective of these two resistors in parallel, is equal to 1 over 5. And if you compare both sides of the equation, we have like 1 to 1 and Rp to 5. So the effective of this resistance of these resistors in parallel is 5. Now this 5 ohms is now going to be in series with these other ones here. Okay, So we are going to have like 10 ohms, then this will be like 5 ohms, the effective, and another 10 ohm. We then find the total resistance, okay, for that series connection, and that is going to be equal to, okay, when you have resistors connected in series, to find the effective resistance, you just add up the resistances, okay, just add it up. So you are going to have the total resistance there to be equal to 10 ohms plus 5 ohms, which is the effective of what we have here, plus 10 ohms, and that will give us 25 ohms. Next question, we have a diagram here. A body of mass 6 kilogram rests on an inclined plane, okay. The normal reaction R and the limiting frictional force, okay, is F, as shown in the diagram. So you have the normal reaction R and the limiting frictional force F. The question is, if F is 30 Newton, okay, if this limiting frictional force is 30 and the acceleration due to gravity is equal to 10 meters per second, then the angle of inclination theta is. Alright, if we compare this diagram to what we have here, okay, this limiting frictional force here is equal to mg sin theta, mg sin theta, and this mg here, the mg here defines the weight of the body. The weight of the body is equal to mg, the mass of the body times the acceleration due to gravity. And from the question, the mass of the body is 6 kilogram, so you have 6 times the value of our g here is 10. So you have 6 times 10, and that is 60 Newton. So this mg here, okay, is the weight, and that here we've calculated it to be 60 Newton. Now, like I said, the force here, the limiting frictional force F here, is equal to mg sin theta, okay, or we can say F is equal to W, since mg is equal to W. So you have F is equal to W sin theta. Now our F here is 30 Newton, so we substitute the limiting frictional force. We have that from the question. This is equal to the weight, which is 60 sin theta. To get the value of sin theta here, we are going to divide both sides of this equation by 60. Okay, so that will eliminate this 60 here, and on this side we are going to have 30 divided by 60. So we are going to have sin theta is equal to 30 over 60, and 30 over 60 is 0.5. So that is the value of our sin theta. How do we now get the value of our theta? Our theta will be equal to arc sine of what we have here. Arc sine is 0.5, the inverse trig, okay. Arc sine is 0.5, and that is equal to 30 degree, okay. 30 degree, that is arc sine 0.5. That means that sine 30 degree is equal to 0.5. This is what this means. So arc sine is 0.5, we have 30 degree. That is the angle of inclination here. Next, on optics and light, the speed of light in air is 3.0 times 10 to the power 3 meters per second. Its speed in glass, having a refractive index of 1.65, is. So what we are required to do here is to calculate the speed of that light, okay, when it enters the glass. Now, since the light ray is traveling from air to glass, then the refractive index is going to be equal to the speed in air divided by the speed in the glass, okay. And from the question, we have given you the refractive index as 1.65, so we say that is equal to the speed in air, which is 3.0 times 10 to the power 8 as given in this question, divided by the speed in the glass, which is what we are looking for. We just denote that as Vg, okay. So next from here, we are going to cross multiply this Vg here, okay. Just cross multiply the Vg here, since this is at the denominator here. So we have 1.65 multiplied by Vg, the speed in glass, and that is equal to what we have left here, 3.0 times 10 to the power 3. To get the value of Vg, we divide both sides of this equation by 1.65. So here we have Vg to be equal to 3.0 times 10 to the power 3 divided by 1.65. Now how do we do this division here? Both of these, they are denominator, 3.0 times 10 to the power 3, while this is our denominator. What we just do is leave this 10 to the power 3 as it is, then just divide this, okay. Just take 3.0 divided by 1.65, and we have 1.82 times, then we have the 10 raised to the power 3 meter per second. So here from this division we have 1.82 times 10 raised to the power 3 meter per second. Next, on waves, longitudinal waves do not exhibit polarization. Longitudinal waves cannot be polarized, okay. It is only transverse waves that can be polarized. Next, on work energy and power, a device that converts sound energy into electrical energy is the microphone. Okay, the microphone converts sound energy into electrical energy, while the loudspeaker does the reverse of it. The loudspeaker then will convert the electrical energy into sound, energy with a greater amplitude. Okay, the sound is, is going to be louder than, the original sound. Okay, so but basically the microphone here is what converts the sound energy, all right, from the person who is using the mic, okay, into electrical energy. Next, on heat and heat calorimetry, a good calorimeter should be of low specific heat capacity and high heat conductivity. You should be able to conduct heat very well. Okay, it should allow for like quick transfer of heat, but it should also be of low specific capacity so that too much heat is not lost to it. Next, on nuclear physics, which of the following is most strongly deflected by a magnetic field? Alright, the first three that I have here, they are radioactive radiations. Okay, now let me start with the last two here, the gamma rays and the x-rays. The gamma rays and the x-rays, they are neutral. Okay, they carry no charge at all, and this is the reason why they are not deflected by a magnetic field or an electric field. However, the other two here, the beta particle and the alpha particle, they are charged particles, and as such they are deflected. But of the two, the beta particle is the lightest of them. Okay, it is the lightest, and as such it is the most deflected or deviated by whether a magnetic field or an electric field. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, on liquid behavior, if a beaker is filled with water, it is observed that the surface of the water is not horizontal at the glass interface. This behavior is due to surface tension. Okay, surface tension, that is the tendency of a liquid rather to behave as though it is covered by an elastic skin. Okay, that is due to surface tension. So the curvature that you are going to have at the glass water interface is due to surface tension. Next, on energy, a dynamo primarily converts mechanical energy, okay, that's kinetic energy, into electrical energy. Next, we have a diagram here. A particle is injected perpendicularly into an electric field. It travels along a curved path as depicted, as shown in the diagram above. The particle must be an electron. Okay, for it to have been deflected, okay, it must be an electron. So the electric lines of force, they move from the positive terminal to the negative. Okay, these lines here is from the positive to the negative. That means that this part here is negatively charged. Now for this particle to have been deflected, it means that that particle must also be negatively charged. Okay, for repulsion to occur, repulsion occurs between like charges. Okay, positive and positive, or negative and negative. So for this particle to have been deflected, that indicates that this here, okay, is negatively charged, and that particle would be an electron. The gamma ray is neutral, so it is not deflected. It cannot be deflected by an electric field. The proton is positively charged. It will be attracted by a negative charge, not deflected. The neutron is neutral, just like the gamma ray, and as such is not deflected. So it is the electron that is negatively charged, carries the same charge as what you have here, which is the reason why it is deflected here. Next, okay, we have a diagram here. in which of the following diagrams is the length of the tube equal to one wavelength? Alright, now what you have here is 1/4 of a wavelength. Okay, it is 1/4 of a wavelength. So for us to get, like one wavelength, 1/4 means 1/4. Okay, like 1/4 of a wavelength. For us to get, one wavelength, that means we need 4 of that 1/4, like 4 of it. So let's look at this diagram. Where can we get 4 of this thing here? If you look here, we only have 1 and 2. This one that is like that is flipped to the other side. So you have 1 and 2. Okay, so this cannot be it. But if you look at this one here, we have 1. Okay, then we have 2. That 2 is from this point here. Okay, from this point here. So we have, let's start again, 1, then 2, then 3, and finally 4. So that means that in here, okay, we have 4 of this thing here, 4 of that 1/4. So this diagram A here, okay, the length of the tube here is going to be equal to 1 wavelength. Okay, because we have 1, 2, 3, and 4. It's like saying 1/4 plus 1/4 plus 1/4 plus 1/4, and that would give us 1. Next on measurement, a calibrated potentiometer is used to measure the EMF of a cell because the potentiometer is preferred for measurement because it draws zero current from the cell. Okay, it takes no current from the cell. Next on quantities, which of the following is a vector? So physical quantities can be classified as scalars or vectors. The scalar quantities are those quantities that require magnitude only. Just their size is enough for their specification. But the vector quantities, they require magnitude and direction. Now from the options that we have here, the vector quantity is the electric field. Okay, so force fields like electric field and magnetic fields, gravitational fields, they are vector. Okay, they are vectors. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next on photoelectricity, the photocell works on the principle of the emission of electrons by incident radiation. The emission of what we call photoelectrons by incident radiation. Okay, the emission of these photoelectrons when light of appropriate frequency is incident on the surface of a metal is what we regard as photoelectricity. So the photocell works on the principle of the emission of photoelectrons, okay, photoelectrons by incident radiation like light. Next on nuclear physics, when an atom loses or gains a charge, it becomes an ion is a charged atom. Okay, an atom becomes an ion when it loses a charge or when it gains a charge. That is when it loses either a it can only lose an electrons. Okay, only electrons in this case. So when it loses an electron or it gains an electron. Now the atom is originally neutral. An atom is neutral originally, but it contains positive and negative charges. Now the reason why it is neutral to begin with is because those charges are counterbalanced, like they are balanced, they balance out each other. But in a case where it loses electron, that means that now it's going to have more positive charges than negative charges. So that atom will become positively charged. It will become a positive ion. That's a cation. But if the atom gains electron, it means that it will now have more of negative charges than positive charges. Okay, so it means that the net charge of the atom is going to be negative. That atom will become negatively charged. It will become what we call an anion. Okay, so an ion basically is formed when an atom loses or gains a charge or electron. An electron, of course, is a charge. Next on waves. Which of the following characteristics of a wave is used in the measurement of the depth of the sea? Echo. And echo is as a result of the reflection of sound wave. Okay, echoing is used in in the detection of submarines using sonar. So ships can use echo to detect the presence of submarines, okay, using what we call sonar. And echo is as a result of the reflection of sound wave when that sound wave hits a hard surface. Okay, next on nuclear physics. Which of the following are produced after a nuclear fission process? So nuclear fission is a type of nuclear reaction where light nucleus they combine together, lighter nuclei rather, they combine together to form an heavy nucleus. So one is correct, and in that process as well, energy is released. Okay, energy is released. Neutrons and protons, they are not formed. Okay, they are not produced. Remember the principle of conservation of matter. Now matter is neither created nor destroyed. Okay, but what we have formed there is an heavier nucleus. Okay, an heavy nucleus, and energy is also released in the process. The energy production in stars and in sun is by nuclear fusion. Okay, by nuclear fusion. Next on it, two similar kettles containing equal masses of boiling water are placed on a table. If the surface of one is highly polished and the surface of the other is covered with soot, which of the following observations is correct? So just to be clear here, the soot is that black substance that you find on pots, for example, like the back of pots where that is, if you are using, let's say, stove. Okay, let's say we are using stove and all of that, that black covering layer that is formed at the back of the pot, okay, is what is called soot. Now in the case of these two here, so we have one kettle that is polished on the outside and another that is covered by soot. The polished kettle, okay, is going to cool down more quickly than the one covered by soot. Why? Because the polished surface is a good reflector of heat. Okay, so the polished surface, the polished kettle, the kettle that has a polished surface, will cool down more quickly by conduction of heat. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at ScholarFedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.